Good morning. In this class, we discuss the relative reactivity of acid derivatives. Relative reactivity of acid derivatives. We can see that the overall reactivity of acid derivative is amide RCONH2, least reactive, then ester, then anhydride or C double bond or R, and the most reactive is RCO, acid chloride or acid halide, RCOX. This is the order of reactivity, relative reactivity of acid derivatives. The order of reactivity is RCONH2 least reactive, and RCOX is the most reactive acid derivative. Now look at here. Here the leaving groups are from this when amide is reacting, the leaving group is NH2 minus. The leaving groups are from amide the leaving group is NH2 minus. Then from ester the leaving group is RO minus. From anhydride the leaving group is RCOO minus, and from halide or acid chloride, acid halide, the leaving group is X minus. These are the leaving groups from different acid derivatives. From amide the leaving group is NH2 minus. From ester the leaving group is RO minus. From anhydride the leaving group is COO minus, and from acid halide the leaving group is X minus. And we know that the leaving ability is depending on the basicity. Now let us see the basicity order of the leaving groups. You can see that NH2 minus is most basic, then RO minus, then RCOO minus, and the least basic is X minus, least basic. When the leaving group is less basic, more will be its leaving ability. So you can see that X minus is a better leaving group. When you compare other leaving groups, you can see that the X minus, the halide ion, is a better leaving group because it is less basic, or you can see that the least basic in this leaving group is X minus. When the leaving group is less basic, its leaving ability will be better. That means acid halide will undergo immediate reaction when you compare other acid derivatives. Okay. Or one more point, you can see that this is the basicity order. Therefore, the leaving ability, or you can see that the stability order is the same. Basicity order is this one, and the stability order is also same. What is that? Most stable is NH2 minus, then RO minus, then RCOO minus, and X minus. This is the stability order, and hence the leaving ability order is what is that? The reverse direction. The immediately leaving group is X minus, and the reverse direction will be the leaving ability. So this is the factor why this order is following for the reactivity. We can see that the most reactive is RCOCl or RCOX, because you can see that from all these acid derivatives, the leaving groups are from amide NH2 minus, from ester RO minus, from anhydride RCO minus, and from halide acid halide X minus. And we can see that the order of basicity order is when you take all these leaving group, the basicity order is most basic is NH2 minus, and the least basic is X minus. When the group is least basic, its leaving ability will be more. It will be a better leaving group. That means X minus is a better leaving group. That means RCOX will undergo immediate reaction. Okay, one more point you can add, when this is the basicity order, the stability order will be also the same. The most stable is NH2 minus and the least stable is X minus. So X minus is a better leaving group. Okay. Now next we discuss different acid derivatives. First one is acid chloride. First one is acid chloride. RCOCl. Okay, preparation. When carboxylic acid RCOH is treated with PCl5 or PCl3 or SOCl2, this you have studied, we get RCOCl. This is the method of preparation of acid chloride from carboxylic acid. Is when carboxylic acid is treated with phosphorus pentachloride or phosphorus trichloride or thionyl chloride, we get acid chloride. Okay, now reactions of acid chloride. You can see that RCOCl, acid chloride, on hydrolysis H2O, acid chloride will change into carboxylic acid to change into RCOH. When it is treated with ammonia NH3, we get amide. RCONH2, we get amide. When it is treated with acid, in presence of pyridine, when it is treated with acid in presence of pyridine, we get anhydride RCOOCOR. When it is treated with acid, any acid in presence of pyridine, we get anhydride, and when it is treated with alcohol, we get ester. That means RC double bond OR, we get alcohol. That means if you want look at it here for this one example, RCOCl, how it is happening, RCOCl, how you are getting ester, we are taking RCOCl and we get alcohol, ROH. HCl is eliminating, okay, minus HCl, then what you will get, RCOOR, you get ester, ester. And how you are getting anhydride, look at it here, RCOCl plus you are treating with acid is RC double bond OH, okay, HCl is eliminating, and what do you get, RCOOCOR, okay, and this way, this is the reactions of, okay, we will continue. This is acid chloride is reacting with water. On hydrolysis, it will change into carboxylic acid. On reaction with ammonia, we get amide, and on reaction with acid in presence of pyridine, we get anhydride, and reaction with alcohol, we get ester. Okay, next is Rosenman reduction. Reaction of acid chlorides. Reduction reactions. Okay. First one is Rosenman reduction. This we have studied. Rosenman reduction. Okay, what is Rosenman reduction? Reduction of acid chloride RCOCl. Acid chloride with hydrogen in presence of palladium, barium sulfate, we get aldehyde, we get RCHO. This is the Rosenman reduction. This we have discussed earlier also. And the second one is reduction with lithium aluminium hydride, LiAlH4. When RCOCl, acid chloride, is reduced with LiAlH4, we get CO group will be changed to RCH2OH. We get alcohol. So and the last one, third one, Friedel-Crafts acylation reaction. Look at it here. Third reaction, the last reaction of acid chloride. Friedel-Crafts. Next reaction is Friedel-Crafts reaction. Friedel-Crafts acylation reaction. Okay, look at it here. Friedel-Crafts acylation reaction. Suppose you take benzene react with acid chloride. We take CH3COCl in presence of anhydrous AlCl3. HCl, here it is H, HCl will be eliminated and you get, what is that, here it is CO, C double bond or CH3, acetophenone. Okay, so you get this compound. So this is about the reactions of acid chloride. So that's all about acid chloride. Next is acid anhydride. Second derivative is acid anhydride. Acid anhydride. Formula RCO or COR. Okay, acid anhydride, or you can write RCO twice, RCO twice, or you can write like that. So acid anhydride. First is preparation. Two molecules of acid RCOOH, when heated in presence of P2O5, phosphorus pentoxide, heated, when acid is heated in presence of P2O5, two molecules will join together and we get RCOO, COR. Okay, look at here, you can see that RC double bond OH. Okay, one more molecule, RC double bond OH. Okay, H2 is eliminating, minus H2O. What do we get? RCO OCOR. Okay, this is the method of preparation of anhydride. And okay, another example, if you take phthalic acid, what is here? Phthalic acid, COH, and here it is COH. This is phthalic acid. When treated with P2O5, heated with the P2O5, you get H2 will be eliminated and you get phthalic anhydride, CO. Here it is O, C double bond O. Okay, you get phthalic anhydride. Here you can see that H and OH. So what you get? CO. Here it is oxygen. Phthalic anhydride. Okay. So acid anhydride. Then now reactions of acid anhydride reactions. Okay, reactions of acid anhydride. Look at it here. RCO OCO are acid anhydride. Reactions of acid anhydride. On reaction with hydrolysis, it will change into two molecules of acid RCOOH. Okay. Then when treated with you can say that or reduction with the LiAlH4, on reduction with LiAlH4, again it will change into two molecules of RCH2OH. Okay, then next is on reaction with alcohol. Okay, you are taking R dot OH, alcohol. You can see that first you get ester, that means RCOO R dash RCOO, and here it is R dot, and plus what you will get RC double bond OH. You get plus carboxylic acid RC double bond O, and this OH RC double bond OH. Okay, you get ester, and okay, these are the important reactions of acid anhydride. Okay, so we continue in the next class. Thank you.